This question is asking us to find the value of each of these trig expressions using the information in both of these trig equations. So in part A, we need to find the value specifically of sine of theta. And the formula for sine of theta is written here. It's the opposite side over the hypotenuse side. Now, those are sides, right? And we don't have a triangle to check out those sides, so we need to go ahead and draw one first. So here's the right triangle, and we also have theta in our expression. So we need to plug in a theta. So let's use this angle here as theta. We could have used it up here, but I'm just going to pick the bottom right one. Our next step is to take the information from our equation and then label the different sides here in this triangle. So we know that cosine of theta is equal to the adjacent side over the h for our hypotenuse, and we have that written over here as well. Well, that's all great, but we don't know which side is the adjacent side and the hypotenuse side in this triangle, so we have to figure out what those are. Now, the hypotenuse side is always going to be the longest side of your right triangle. So the longest side is this side. So I'm going to draw an arrow there and say that that's h. And the denominator had 25, and if our denominator is h, then that means that this side right here is going to be 25. The next thing I like to do is to call out the opposite side, and I draw an arrow from my theta to a side. That's going to be the opposite side. So I'm going to say O for opposite side. But do we need the opposite side? No, we're going to look for our adjacent side. Well, the adjacent side is going to be the last side, and that would require an arrow kind of curving around here. So this is going to be A for adjacent, and it looks like that's going to be in the numerator, which is 24. So this side's going to be 24, this side's 25, and this side we don't know. Well, now we want to figure out the ratio that matches up with sine of theta. So I write that down here, sine of theta, and we know that that's going to equal opposite over the hypotenuse. Well, we don't know what the opposite side is, so I'm gonna say that let's use x for the opposite side because the O looks like a 0. So in our numerator, I'm going to use x there. And then in the denominator, it looks like we have our hypotenuse. So our hypotenuse is 25, and I plug that in there. So now we have to figure out what our x is. And to do that, we're going to use the Pythagorean Theorem because we have a right triangle, and we have two sides of that right triangle. So here's the formula. A squared plus b squared equals c squared. And the a and the b are just the legs of this right triangle. So the legs are going to be the sides that go off from the right angle. So that's going to be a leg, and then this side over here is going to be a leg as well. So the leg looks like it's x and also 24. So I put x over here and I square it. I also take 24 and I square that too. And then lastly, c, what the Pythagorean theorem is set equal to, well, c squared, is actually going to be the length of the hypotenuse, which is 25, and that's also being squared. So 25 squared. And now we just have to solve it. So I have x squared, I'm just bringing that down, and then 24 squared is 576. That equals 25 squared is 625 right there. Now to get x squared by itself, we want to take away this 576, so I subtract it from this side. Means I also have to subtract it from this right side. That leaves me with x squared equals 49. Now we need to take the square root of the right side and the left side because I want to get rid of this x squared, and to do that you do the square root. So now I'm just left with x on the left side, and that's going to be plus or minus 7. That's the square root of 49. But we only want the positive version of x because, well, we can't have a negative as a side of a triangle, right? So I take my value for x there and I plug it into that x. So sine of theta is going to be equal to 7 over 25. That's going to be the final answer. Part B is going to be done the same way, except we're looking for tangent of theta. So the first thing I'm going to do is draw another right triangle. There it is. And just to do something different, I'll put theta up here just to show you it doesn't really matter where it goes because you're going to plug in the sides accordingly. Now, we have sine of theta right here, but before we even do that, let's just go ahead and label all of our sides. So the longest side is our hypotenuse, so we'll say that that's HYP, and then across from our theta, that's always the opposite side, so I'll label that as OPP, and then the remaining side here where you kind of draw a curve to, that's going to be the adjacent side, so we'll say that's ADJ. Now back to sine theta equals 3 over 5. Sine of theta is the same as opposite over hypotenuse, so that means that our opposite side is going to be 3, and then our hypotenuse is going to be equal to 5, right? Because O matches up with the 3, and then the H matches up with the 5. So on the opposite side, I'm going to put that as 3. It should be a 3. There we go. And the hypotenuse is going to be a 5. And now we got to figure out what tangent of theta is. So I'm going to write tangent of theta here, and that is equal to the opposite side over the adjacent side. So the opposite side of theta here we said was 3, so that's all good. And then that's going to be over adjacent. In the denominator, we don't have the adjacent side here, so I have to plug in an x. And just like my previous part A, we want to use the Pythagorean Theorem again to figure out what this unknown side is, which is x. So I want to take the two legs of my right triangle, so that's going to be one leg, this is going to be the other leg, and I write them down and I want to square them both and add them together. So x squared added to the 3 squared, and that's going to be set equal to the hypotenuse squared. And you do that every time for the Pythagorean theorem. Okay, it's always set equal to the hypotenuse being squared. Okay, now I want to actually square these things. So x squared is leading the way, and then 3 squared is 9, 5 squared is 25. I want to solve for x squared, so I want to get it by itself. That means I have to take away that 9 by subtracting it, and I take away from the 25 as well. It means I'm left with an x squared equaling 16. Now I want to get rid of the squaring of x, so I take the square root of that to get rid of it, and I do it to the right side as well. So I'm left with x equaling plus or minus 4. But, of course, the side of the triangle can't be negative, so I'm just going to use my positive version. And now that I know the value of x, I throw it up there for that x, and I know that my tangent of theta is going to be equal to 3 over 4. And that's my final answer.